Hello everyone. So this is our fourth video in this series that I've decided to call Creating Vectors in the C Programming Language. And the fourth video here is going to discuss identifiers in C. So far we have discussed the need for dynamic arrays and memory in C, especially the call stack and the heap, what these two structures are, how they are useful, what their purposes are, how they differ, and how a low-level programming language deals with them. Not just C, any low-level programming language, C++, Rust, etc. So this is a rather important topic, and if you do not know what these things are, or you like a refresher, I'd really recommend checking out the previous video. That's just titled, Memory in C. It's a fairly long video, 43 minutes long. Even I did not know that it will be that long. I was just too busy and just yapping about one of the most favorite topics in low-level programming language. And but I think it's worth the time investment as you learn a lot of things. In the current one, we are going to learn about identifiers in C. Now, if you've ever written even a single line of code in any kind of programming language, you have used identifiers. Even if you do not know what identifiers are, you have used them. Trust me, I know more than you. Okay? So you have used identifiers even if you do not know what identifiers really are. Identifiers are the building blocks of any programming language. Any programming language will have identifiers, and C, being the mother of all, definitely have identifiers in them. So identifiers in C. So identifiers are names used to identify any user-defined items in a programming language. Any user-defined items. Okay. Now, a lot of the code that you use or whatever applications you'll be building in any kind of programming language will use a lot of outside code, maybe a lot of standard libraries, maybe imported libraries, and all these things. But there will also be code that you yourself write. So that's why any user-defined item in a program is an identifier. Sorry, identifiers are used to define these user-defined items, right? Identifiers are, you can just think of them as names, like how names are used to identify different kinds of people or different kind of dogs, right? Like Michi, my cat. Well, my ex-cat, that bastard ran away. But okay. So identifiers aren't unique to just C and can be found in any programming language, just maybe with default uses. As I said, if you've ever written even a single line of code, you know what identifiers are. So again, they are just not unique to C. They are available in any programming language. They are very needed to just write programs. And yeah, so C has variables, constants, functions, types. Okay, these things are in C. In Python, we have lists. Then we also have classes in Python. We also have classes in Java or C++, or well, not in Rust, but Java and C++ and Python. And their objects in Java. Yeah, so classes and their objects. Both of these things are identifiers. Well, they have an identifier. Then vectors in Rust or C++, again, these are all identifiers. They fall under the same category. Identifiers. Excuse me. Yeah. So identifiers in C are needed because, well, you just need to define name for any kind of code that you're writing. So any section of code or any variable you're declaring needs a name, and thus it needs an identifier, right? So C is not an object-oriented language like Python or Java. C does not support classes. It's purely functional. The main.c file that we saw earlier, it starts with the main function here, right? Main, int main. Int main is the entry point of any C code. This thing runs before anything else. And this is a function. As you can see, it's not a class, right? If you've ever used something like Java, then public static main, void string, args, that thing is a method that is inside your class that bears the resemblance of the file name itself. So if your file name is something like program.java, program.java, then this file will have a class named program. And inside this, we'll find various different methods. One of them being public static main void string args. Okay, the main function basically, it's found inside a class called program. That's not the case in C. In C, the main function is just a function that's in your entry file. C is not an object-oriented language like Java. It does not have classes, and thus it does not have any class methods, any class objects, and anything like that. But it has constants, variables, and functions. Very simple blocks that somehow run your entire computer architecture. Like anything you know, that anything that's available on the computer, anything uh, you can see right now, anything that you can use is either using C or highly inspired by C. And C only has constant variables and functions. That's basically it. It has a few other things like called macros, types, and all those things, but for now we are just going to discuss constant variables and functions. Okay, so constants are identifiers that cannot be reassigned a value. I've given an example here of what a constant declaration looks like in C. So here, pi is the name of our constant. Constant is defined with a const keyword preceding the whole line itself. So you firstly define the const keyword, then the type of what the variable is going to be. Here we have used float as the number we are trying to store inside pi is a decimal number, and decimal numbers are stored with the type float. And then finally, you define the name of your constant. What are keywords again? Keywords in C are just specific words that are chosen by the creators of the language that are used to declare something. So here, const is being used to declare this constant called pi, that is 3.14. So another thing you might have noticed here is that I've written the constant name in all uppercase here. That's just a convention to easily identify what a constant is. That's not compulsory. You can have something like pi here, but it's recommended to do this because in like hundreds or thousands of lines of code, uh, having something that has a full uppercase name will just instantly tell you that yeah, it's a constant. So that you don't actually try to reassign something like this a value. So once you've declared something a constant here, because I've declared pi a constant, I cannot change its value because so if I go and do something like this 3.142 after this, the compiler will throw an error because this is not possible because this is a constant. It's fairly useful in cases where we do not want to change something's value, like pi. Because if later down the line in your code, if you accidentally change pi's value to something like 2 and your program is doing something like physics calculation or mathematical calculation regarding area, circumferences, or volumes, then this change will be lethal. So again, constant change. Pi is a constant, constants are used so that a value cannot be changed. Next up, we have variables. Now, yeah, so constants cannot have their values be changed, but in many cases, you might actually need the values to change. Because if you're keeping track of something like a count, it will start from 0, and each time the count should increase by 1, 1, 1, and so on. So count's value will be finally 3. And you want something like this to happen, and thus you need something that can change in value, and thus you use a variable here. So here, unsigned int, unsigned is uh, this whole part is a type. Okay, unsigned int, this whole thing is a type, and this is the variable name. There was no need to do this. I just used this as an example to showcase the different kinds of types that are available in C, as that's the next chapter after covering identifiers. So even something like, int age equals to 20 is correct. It's a valid variable declaration with of the a variable age. Then something like float balance equal to 2.12. I'm a broke guy, so I just only have $2.12 with me. So this is again a valid variable declaration. Ignore this actually. So this is how it's being done. This thing is the type of the variable, and this thing is the name of the variable, right? This name here identifies this whole variable. This is a variable declaration, and the name age helps us identify this variable that has the value 20. I hope that wasn't confusing to you. So purposes of both constants and variables is to store some data. Here too we are storing the data 3.14, and here we are storing the variable, here we are storing the integer 20 inside age. Both are used to store some data, but what if you want to perform certain actions? What if you need something to declare certain lines of code that need to be called a multiple number of times? So that's where something called functions help us. So functions are helpful when you need to perform a certain action multiple times across your project. They allow you to not have to copy and paste the same code again and again everywhere you need. Instead, you can just call a function. So here I have added an example of what a function declaration looks like in C. So what is a function here? A function is just a piece of code that does an action. As the name suggests, it has a function. Okay, a function has a function. Now, what is that function? A function basically does a task. Functions do a task. Okay, you declare this task inside a function scope. We discussed in the previous video when we were discussing about what a stack is and when something goes outside of the scope. So these curly braces mark the scope of what a function is. So any business logic, any task, any instructions that you have for this function will be written inside the scope of the function, inside these curly braces. So this is a piece of code that is related to this function called square num. So the function called square num just takes an input here that's called num. This is again just, this is the type, and this is that argument's name, num. So this function takes in an input that's called num and then squares it and then returns it. Okay. So the above function is an example of a simple function that squares any integer you pass into it. So you pass an integer here and it squares it to you and it returns the value outside. Okay. So you can have something like, okay, this shouldn't be void, this should be int here. I apologize for this mistake. But this function is returning num into num, square of an integer, and square of an integer is an integer. The type here, type before the function name, is used to declare the type of what the function is going to return. And here we can clearly see that the return function returns an integer multiplied by an integer. Now an integer multiplied by an integer is an int. So this shouldn't be void, this should be int here. So what you can do here is that you can store what the value this function outputs. Okay. So firstly we'll see what a function call is, and then we'll see how we can store this value inside a variable. So in the above function, num is a parameter because num is an input. Okay. Num is a parameter here. Now, the two words parameters and arguments are used interchangeably to one another. I too, just a few moments ago, called num an argument, but num is actually a parameter, right? It's just a nitpicky stuff, technical thing. It's not actually needed, but it's good to know what actually parameter is. Okay. So this num here, it's not just any variable, it's a function parameter, a function's parameter of the type int. Okay, a function's parameter is just a variable that can be used inside the scope of the function. So again, I discussed earlier scope that scope basically encapsulates the function's business logic. So this variable, this parameter here is only valid inside the scope. That's where we are using. If you use it outside the function square num, it won't work. It will throw an error. Okay. So square num 5 is a function call. This square num 5 is a function call. Here we are passing 5 as an input into a function square num, right? 5 is the function's argument here. Square num is a function call with 5 as the function's argument. Num here is the parameter, right? Num is the parameter. And the value that num is going to hold because of our function call is the function's argument. Okay. So basically what happens is that num becomes 5 because we are entering a value inside this, right? So this here is a function call. Now, what if you want to store what the function returns? Because let's see, you do not want to do the square operation by yourself. Instead, you just want to call this function again and again and store the value of whatever the function returns into a variable. So you can just do it in this way. Now, mind you that this should be what? This should be an int here. So you can again just simply declare a variable int, right? Let's call this sq num, right? And then we just have square num 5. So now what will square num 5 return, right? It will return this. What is the value of num here? The value of num here is 5, right? So basically this into this, 5 into 5. So it will return 25. Okay. Now that's the output of this function call, which can again be stored into a different variable called square num here equals to square num 5. Now num is 5, num is 5, 5 into 5 is 25. So square num gets the value 25. Why does it get the value 25? Because we are returning this. Okay. If we do not have this return value, if we do not have this return keyword here, this value, this value won't be returned from the function. In such a case that the return is truly not there, this will truly be a void function. But because we have this return keyword here, this is not a void function. This function actually returns an integer that can be used. Okay. So again, a function's parameter is the input value while the argument is the value passed for the parameter. Sorry, a function's parameter is the input variable while the argument is the value passed for that parameter. So here num is a parameter while 5 is the argument. And that basically concludes identifiers in C. That's all we had. We just needed to cover 3 different topics: paths, constants, and functions. The next thing we have are types in C. Now, types in C are very important because C is a statically typed language. Everything you define needs a type in C, as we previously saw. That even the function here has a type, even the function's parameter here has a type. Even in the previous examples here, even the constant pi has a type float, even the variable age has a type int. Everything in C needs a type, and that really helps out the language. and we'll see how and why types are important in C. And that's all for this video. It was a pretty simple one, identify in C. I hope it wasn't too difficult. And thank you for watching. Bye bye.